Hi everyone, it's Deb from Deb's RV Services and welcome to today's video. I'm very excited because I have a special guest today. I have Joe with Bubblehead RV and we're talking all about solar. This is like a Solar 101 class, so go ahead and get out your pen and paper and get ready to take some notes, and I hope you enjoy this week's video. Okay, I have with me today Joe from Bubblehead RV, and we're going to talk all about solar today. So, what I'm
We'll
going to do
try.
is let Joe introduce himself, and he can tell us a little bit about his background and what he does.
All right. Hi, I'm Joe with Bubblehead RV. I've been in the business. I've been working on RVs for about 5 to 10 years. My wife and I have been full time for going on 7 years now. And we went through the National Academy here in Athens, Texas, and took all the classes, went through fundamentals, all their different courses, plus solar and generator. And so my business, I own my own business. It's Bubblehead RV, and we're mobile. So we travel not only to Arizona, but Texas and up into Michigan, and just really wherever we're at, we find business available. So definitely have had a lot of experience. I was working on a solar job today with a friend of mine. And so, yes, that's kind of who we are.
Okay, so you not only do solar, you kind of do everything, but solar is something that you started specializing in.
That's correct. It's one of our areas that we like to focus on. I did my own solar build after attending the class, and sorry about that. Attended the class and wanted to do a solar build for mine, so I did what was called a whole house replacement. Put in two quattros, or two basically 5,000 watt inverters, and it's essentially running our entire home if we don't have power. So it's pretty expensive, a lot of wires and components, but definitely a learning environment for sure
Yeah.
to have done.
Oh, I can imagine. So, what I guess where I
Yeah.
wanted to start out today is for like the person that wants a basic solar system, what would it take for them to have something just to start out that's not going to be as expensive as like a system like you were just talking about?
So good question. There's a lot of players in the industry, if you will. You've got Vamp, you've got or Zamp rather, and you've got Furion and some others uh, that have started putting together basic off-the-shelf kind of products. You don't even have to mount them. I'm sorry, you don't even have to mount them to your roof or any of that kind of stuff. They're actually those that you can just have outside your rig. Have a couple of portable ones, and they plug right into your batteries, and they charge the batteries during the day. And that's really what solar is. It's just another way to recharge those batteries. So there's very inexpensive methods to off the shelf with that, and then it gets exponentially more expensive as you go up to really tailor to what you want. And that's the great thing about solar, is that you can modify or change your setup. You can start out small and then build build upon what you've gotten. You just want to have that in mind. If the goal is down the line to have a system like mine, you want to put those more um, the systems in there that will allow you to advance without having to replace, if that makes sense. So you're not having to rebuy things over and over and over just to get bigger.
Right. So like for a person would first have to figure out what do they want to run off the solar. So if they're just looking for charging their phones and maybe using a television, a computer, simple things like that, they may not need as big of a system. Like they could use
Right.
something like if they only had say they had one battery or two batteries to start with, and they wanted to have some solar to charge that one battery or two batteries, they could do that. But they're not, if they have an inverter installed. So I guess let's also break it out into components for that person that doesn't understand. Like solar is there to charge the batteries, but it doesn't mean
Correct.
that you're then going to be able to use your TV. In order to use your TV or any of the 110 outlets, now you have to bring in the inverter part of it.
Right. Right. So that's a key part of this is understanding just the different components that are involved. Solar is simply the panels that are on your roof, and they come down through a controller. MPPT controller is typically what we use, and that modulate or that controls the voltage going to that battery bank to charge those batteries. Because if you overcharge them, it'll kill the batteries. It'll just basically, for lack of better words, it'll burn them up. Um,
Hmm.
so that's the basic there. Then if you want to run your air conditioning, or you want to run a TV or your microwave or anything that you plug into the wall normally at home, now we have to have an inverter. And depending on what you want to run and for how long, now we start talking about if you need 1,000 watt inverter, a 2,000 watt inverter, a 3,000 watt inverter, or up like I'm talking about where I have two Quattros that are 5,000 watt inverters. So I have literally 10,000 watts of power that I can suck out of my batteries, and it'll take my batteries away very quickly if I do that.
Which would be
So
so
that you
awesome
just
to
got to
have that kind
understand
of
what
a system.
what
But
the
yeah,
whole load is.
yeah, it does.
I'm
And
sorry,
that's
say that
something
again.
that's okay. That's something that is it's good to talk about too, is that the batteries are dependent on how much sun it gets, how much this, if you have the solar on the roof, and if you're getting sun, and that battery bank and how full it is. Because you can have the biggest
Correct.
inverter out there, but if your batteries are not full, then you're not going to have anything for that to draw on. And I think that that's where some of the people out there get confused. They think, oh, I have solar batteries and an inverter. Now I can run my stuff. And even if you say, well, yeah, you could run, like for instance, I have a 2,000 watt inverter. I can run an air fryer on that. It will take it. The draw of an air fryer is about 1,500 watts. If I have sun coming in, it's in the middle of the day, I will have enough battery power so that it can invert it and I can run the air fryer for maybe 5 minutes or 8 minutes or something. But what people, I want them to understand, and we can talk about, is that in the evening, as soon as that sun goes down, you are going to deplete those batteries. And a lot of people will get
Right.
that beeping noise at night that will tell them their inverter's shutting down, and they're not understanding because they say, well, I have an inverter and I have solar and batteries, so why is it beeping at me? So maybe explain
Right.
how the inverter automatically will shut down, and kind of what that's all about.
So the inverter has settings, presets, if you will, that you set in there, um, and you can change those values, but they're preset from the manufacturer of, say, Battleborn or Big Beard, or depending on who you're going with on your batteries. They have a level that you want to turn the inverter or any draw off of that battery, because if you deplete that battery completely to zero, the battery has no way to know. Its BMS, its battery monitoring system, has no ability to turn it back on or to start charging even. It uses electronics to control that process, and to protect those battery cells. So we have a set value in there, and it's typically 11.2 volts. Um, for lithium, but you set this floor, and that's a safety feature for that battery. And so what happens is at night, let's say you have two batteries, two Battleborn batteries that are 100 amp hours each, and so you have a total of 200 amp hours. If you're running a lot of, let's say you turn on the air conditioner, that air conditioner is going to take normally about 10 amps if you were just running it plugged into the wall. But when you invert it, it's a factor of 10. So 10 amps becomes 100 amps. So you can see in 2 hours, and actually less than 2 hours, because you have other things, incidentals running, you're going to deplete those batteries. You're going to totally eat the batteries. So even though you have that 2 or 3,000 watt inverter and you have two batteries, depending on what you're running at night, you have nothing filling the bank. It's like think of a a bank with money in it. If you keep withdrawing money without putting money in, pretty quickly you're going to run out of money and hit that zero balance. And it's the same thing with your batteries. You keep drawing energy out of it without putting energy in, you're going to hit that zero and you have nothing left to give. And that's why they shut down. It's protection for that battery.
Yes. Now you said air conditioner. Did you mean air fryer? Because you said 10 amps.
Uh, yeah, the air conditioner initially, if you have a soft start on it, it'll
Ah,
bring that
okay.
initial. Yeah, that's why you wouldn't run an air conditioner without a soft start. And I apologize, I should have said that.
That's
But
okay.
your
Yeah,
initial start amperage, yeah, I'm sorry, I'm talking numbers
that's
and
okay. Well,
I get lost in it.
you were just on this big install, so you're thinking about all of that in
Yes,
the air conditioner and everything else. Because I was
right.
thinking 10 amps for an air conditioner, but you're right. If you have a soft start, because there are people out there
Yeah,
that might want to have a system that can run an air conditioner, but having a soft
actually,
start
yes,
reduces the amperage.
it
So that's what
it
makes it
does. It does. It
the
helps
ability to
helps
work.
it helps it run a whole lot less.
Yes.
But the same
So,
thing, I mean, if it's even at running that air fryer, like you said, 1,000 watts or 1,200 watts, you're pulling a lot of amps because you're inverting it and it's times 10. So if it says 10 amps on the side, it's 100 amps when you invert it.
yeah. So yeah, it really is and I think that's the thing about it is that you almost can never have enough solar because the more you get in there, the more your battery bank can stay full. At nighttime, I
Yep,
want people to understand the difference between using it in the day versus at night because at night you have nothing else to fill your bank with, but it
right.
just depletes it at night. Um,
Yep,
so let's see. We kind of talked about I don't know if we really actually established a basic system, but wouldn't you say if you just wanted to run something that I always think of my system and I tell people that on my channel, but because my system is considered a small system, I only have two AGM batteries. I don't have lithium yet. I have 400 watts of solar and a 2000 watt inverter. To me, that seems like a pretty basic system if you're going to have the inverter, if you want that whole kit and caboodle, people could just
right.
have solar to charge their batteries. But if you want something to just give power to outlets, have a TV and charge, I think, would you consider that a basic system?
I would, because you're very small in nature of what you can power and whatnot. Even though the invert, as soon as you start talking inverter, now we have to talk about rewiring things and whether you still need a converter or not, depending on the inverter. And but yes, that to me would be a basic system, what you described.
Okay. So if you
But
wanted
you can
to,
go more basic than that,
okay,
obviously. But when you talk inverters, adding an inverter in there, that would be what I would say is kind of the baseline or a basic system, a 1 to 2,000 watt inverter. 'Cause some folks, some of the RVs come with an inverter that runs just an outlet in the bedroom and maybe
mhm,
an outlet in the kitchen because they have a residential fridge. So there's even more of a basic, they're just two plugs that are run off that inverter, and that's all you get. So it can even
true.
scale down from what you were talking.
Okay, okay. The next thing I want to talk about is the difference between lithium and lead acid. We have, when you change out to lithium, some people think, well, I want lithium batteries instead of lead acid batteries. There's a couple other things that you have to take into consideration because you have to also make some
Yes,
modifications because of the type of voltage. So, can you go into that a little bit?
that's true. Yeah, so the lead acid battery doesn't take as high. It typically is running at 12.6, 12.8 volts. So it's going to charge around the 13.2 volt um, range. And so your converter, which is when you're plugged in, your converter actually charges that battery bank. And some converters will be able to auto detect that you've shifted from lead acid to lithium batteries. Others don't, and some of them have dip switches. But bottom line, if if you shift over from a lead acid battery to a lithium battery, you have to have a converter that is set up to charge that lithium battery. Because if you only charge a lithium battery at 13 volts or 13.2 volts, you're never going to reach that 14 to 14.2 volts that a lithium battery needs to fully charge. And so you're never getting to 100%. And it's like trying to run at 75% all the time, and it never gets a full charge. So it's not good for that lithium battery. Um, so the difference there, the other thing to talk about is that lithium batteries allow you to have, let's say it's a 100 hour amp hour lithium battery, you have 100 amp hours of usable power there, even though we set a floor for the BMS and whatnot, but you essentially can use all 100 amp hours of that battery. If it's a lead acid, if it's a 100 amp hour battery, you can only use 50% of that because you will damage that battery if you get below. So even though it says 100 amp hours on the lead acid, you only have 50 usable amp hours on that battery. So there's a big difference there. Weight is another consideration on them. Lead acids are a lot of times very heavy as compared to 100 amp hour lead acid versus a 100 hour lithium. The lithium's much lighter, and the gases that are produced in a lead acid, are explosive. So you've got to have that vented, whereas lithium, you don't. You can have that inside the coach. You very flexible on where you can mount those. So there's a lot of benefits to shifting to lithium. The only downfall is the cost.
Right.
The initial out of the gate cost is a lot more expensive for lithium.
And they last a lot longer too, though, right? Don't they have, isn't it like a
They do.
10-year lifespan?
They
Okay.
do. Some of them, they've gotten a lot better in their technology and how to with these BMSs that really control the charging and equalize, each of the cells and stuff. All that plays into the life and longevity of the battery. So the lithium batteries are getting to where they last even longer than that. And lead acids, you think about your car, at 5 years, if you've got the same battery at 5 years, you're really lucky that it's lasted that long. So um, it it just is lifespan and cost and all those things going into it. It's actually cheaper to go lithium, but it hits you all up front by over time.
Right. Now, with lithium, and this is something that kind of confused me too, aren't there different types of lithium? When people talk about the type of lithium that's explosive, what is that, and what is the difference? And there's something like you want to have some kind of, if you're in cooler temperatures, you need like a little heater. Can you just kind of go
Yeah,
into that?
yeah. So early in the lithium development, when they first started coming out, remember back when we used to fly and stuff, and they would say that if your phone had a lithium battery, that you couldn't bring it on board because they were having such problems with those batteries overheating and actually exploding. Because they'd go into a runaway situation where they just kept heating and heating and heating, and it was catastrophic. So they've now fixed that. That's no longer really a problem with lithium batteries. But you did bring up a really good point, and that's that charging the battery, if it's below freezing, some of the manufacturers say that it will damage the battery to charge it at anything below freezing. Battleborn has done a lot of tests. There's videos out there where they actually bury them in snow and charge them and deplete them and that kind of stuff. And one of their claim to fame is that they can charge and discharge at any temperature. However, they do sell heated batteries, so kind of
Yep.
defeats the purpose. But for the mainstream battery out there, you want to be careful with your climates. If you're going to be living in Colorado and cold up Montana and that sort of stuff, and that's where you're going to reside and camp, then you really have to pay attention to the cold weather. You're going to need to put down. You'll have to have some way of heating that battery, whether it's depending on where it's located. If it's inside the coach and you're keeping the coach at comfortable temperatures, you're not going to have a problem. If it's in outer bay, like where I keep mine, then you got to monitor the temperatures there and have a way of heating that area to keep it above freezing for your anytime you're going to charge those batteries.
Okay, very good. So, as a certified inspector, I inspect these solar systems, and I'm looking at all the
Hmm.
wires and for the batteries, the inverter, and everything else. And what I would like to know is, what should I be looking for as a sign that this system is not hooked up correctly? We have people out there that are not certified techs, maybe, or they just learned how to install solar, but they are not, they're actually, it's pretty dangerous that they are putting these systems
Right.
together and they're not backed by a certified inspector or a certified tech or a company, and they can cause their fire hazard. So what are some of the things that, as an inspector or even other people out there, that they could look for to see what is, I guess, not installed correctly versus what is installed correctly?
Well, first let me address the fact of using certified technician over run-of-the-mill, handyman guy that just wants to help out. Most of those folks are well-meaning. They want to help. Most of the folks in the camping community are always willing to help and want to, see somebody enjoy their weekend and try to fix whatever the problem is. The problem is with that is you don't understand the complexity of dealing with solar and with the inverter and dealing with um, all the systems that get combined there, and so that's kind of it's almost like having somebody who's a neighbor coming over to work on your brakes versus taking it to a certified technician that knows the difference and knows what to look for in that braking system to tell you, yeah, this is no good. We can't just put this back together because you're gonna be driving down the road and you are in danger. Same kind of philosophy on the RV and dealing with solar, and especially in electrical. Um, I just went through an entire, I guess, season, if you will, of doing um, recalls that were done on the solar systems that were installed incorrectly, and they were a fire hazard. And it was a recall on an entire class of RV where we had to go in and remove some of the parts and put them back. Again, dealing with electrical heats up, bad connectors, those sort of things, um, they will cause a fire. So, I guess enough beating on that drum. For an inspector looking at the system, to look for evidence of heating, overheating. I don't know if you guys use the infrared or where you take temperatures. If you're able to do that, actually taking temperatures of those connections where that solar system is made, if they are glowing hot, that is a red flag, obviously, that there is a problem with those connections. And you can do that on any setups with the batteries, but definitely in the solar world, where those connections are made, and discoloration in the wiring. That's a big telltale that they've been overheating. And then do you guys get on the roof and inspect the roofs as well, right? So
Yes.
looking for fuses, they should have a fuse on each one of those lines going into the junction box, if you will. And so they should be fused just like any other power source because they're providing a lot of amps down those wires. And if they short out, they could cause major problems. So looking for, proper fusing, proper connections, any, I'm trying to think of anything else that could be a glaring
Size
thing
of the
that
wire,
someone that
like the
wire
size of the
sizing
wire.
is a big, yeah, yeah. Wire sizing is kind of a big thing. You want to make sure that if they have like 50 panels all going into one and they're really thin gauged wire, that's kind of a no-no. And if you walked into someone and they had a outlet that had multiple plugins going into that one outlet, that would throw a red flag to me. That's pulling way too much current into that one outlet. Same thing if they've got, excuse me, if they've got 15 panels on the roof and they're all going down one thin wire down below, that's way too much power for that wire to handle.
Right.
Does that
Now,
kind of make
something I
sense?
was thinking about is a friend of mine had her inverter installed in a cargo bay, and she didn't have any
Excuse me.
over the top of the inverter for very long. It was just something that I had noticed, but I thought, wow, that's something that people should probably think about too. You don't want to cover an inverter because isn't that there, like there's a built-in fan on these systems that help keep it cool. If you were to
Yeah.
smother it by putting, it could be blankets or
Excuse
over
me.
the top, then you're not allowing it
Yeah.
to actually breathe, and that could be a problem too.
Right. Yeah. And the complexity that a lot of us find. I just did a solar build in an airstream, and there's no room in an airstream. There is just no room. Excuse me, I'm a cough. But in a lot of the RVs, they're small and there's just no room. So you'll try to make things fit the way they can, and so you want to allow at least 4 to 6 inches over the around that inverter for it to breathe and to have ventilation because it is a big heat source. It is taking and converting electricity from AC to DC. And if you open it up, you'll see there's a huge bundle of wire there that they have to make that inductive, the change, if you will, the magic from DC to AC to invent that AC, and it causes a lot of heat. And the same thing with the solar. When the solar is sending electricity down, if your battery bank is full, that power has to go somewhere. So on the back of those MPPT controllers, they've got fins, and those fins basically allow that heat to dissipate. If you've got that compartment so packed that there is no ventilation or no room for ventilation, then you're begging for a fire. You're begging for just like you were saying, having a blanket or something over the top of it. You're smothering it, making it work harder, and compiling the problem's just going to continue and get out of control.
Right. One other quick
Cleanliness
question.
too. Cleanliness is another thing to, I'm sorry to
Oh,
interrupt, but
right,
definitely
right.
cleanliness, looking to see if, especially we have a pet, love our dog. She sheds like if there was a, if, if she could donate hair, she'd be a millionaire. But you've just got to keep those areas clean because that hair just packs and it gets sucked into them. And now it is not able to work efficiently.
It's all the systems in an RV. That's what something I talk about all the time is trying to keep everything clean, free from hair and dust, debris, because it
Right,
stops everything in our RV from working.
right.
So,
Very true.
well, good. One other quick question, and it's a
Sure.
little bit more. It was a question I had from somebody about the difference between the automatic shut off on an inverter when you have AGM versus lithium, or lead acid versus lithium. Uh, I think that it was set for, you mentioned 11.2, but I know that my friends who has lithium, hers is set at 11.9. Now, I could understand with your lead acid and AGM batteries, the inverter shutting down at 11.9, but if you have lithium, is it supposed to shut down at 11.2, or why can't it shut down when the batteries are because you can take them to almost empty, so why is it still at that
Right.
level?
So lithium batteries have their makeup or their design, if you will. If you look at a flow chart, or not a flow chart, but a chart, if you charted the voltage on a lithium battery, it stays steady state all the way through, even though it's at say 50%. It's not like a lead acid battery, where a lead acid battery, the voltage drops as you get 50%. So you'll see that 12.0. If you're at 12.0, you're at 50% on a lead
Mm-hmm.
acid, right?
Mm-hmm.
Not so with a lithium battery. the voltage stays constant until the very end of its life, and then it drops off
Wow.
significantly. So that's where I said 11.2, it is 11.9. So it's set there because once that starts dropping, you're at zero. You're at the bottom
Okay.
end of the lithium battery. So that,
That
yeah,
is
that's
good. That's
why,
good information.
yeah, that's the difference in their makeup and how they charge and discharge, and lithium just is, it's made to keep that constant power level, and that's better for the equipment, and that's kind of why they designed it that way, is because keeping that constant voltage and amperage keeps everything working, all your equipment working better, whereas as it's dropping, as voltage drops, amperage increases. So on lead acid, that's what's happening when you're dropping on that voltage. Your amperage is going up, and
Hmm.
that's heat, and that's bad for the equipment.
Yep,
Another
absolutely.
reason to go to lithium.
That's right. You sold
They're
me,
not paying
Joe.
me, by the way. No,
Right.
nobody's paying me, unfortunately.
Yeah.
But
Well,
I'll
it's
do
next
the
on my
installation.
list. Okay, well, that is awesome. I think that's good information, and I think we covered all the questions I had, and we're at about a half hour now. So,
Okay,
why don't you just tell everybody
perfect.
how to get a hold of you if they want to reach you for any of your services?
That's a great idea. I don't know. Joking. I have a Facebook page. Um, my email address is bubbleheadrvtech@gmail.com. And then my phone number is 214-605-8534. And you can just Google us, or if you go to the NRTVA website, that NRTTATAA, I forget what the website is, but
RVTAA.
thank you. That website, you can find me there, and I keep on my Facebook page. I update where I'm going to be and the duration that I'm going to be there. It's essentially Michigan in the summer, Arizona in the winter, and somewhere in between. In between, so
Perfect.
we could definitely schedule. Yeah, and I'm good to answer questions or do installs or whatever folks would like.
Awesome. All right, Joe. Well, thank you so much for being on here. I appreciate it. And
You're welcome.
yeah, and then don't hang up because I'm going to stop this and then it's got to upload everything.